Hello everyone, I am Chalma Reddy. Welcome to CR Maths class. Today I am going to discuss a new chapter, probability. This is a very important chapter. So this chapter already you know very well. You all must have heard of this term through not in academic sense, but relating to many other events in your life. Some famous examples are in betting, chance of winning of Indian cricket team, or while playing Ludo, the probability of occurring six on the face of a die, while playing cards. These examples are, we know that in general life. Okay, so basic definitions I am going to discuss in probability. First, random experiment. What is random experiment? A random experiment is an experiment in which the experiment can be repeated any number of times. The experiment can be repeated any number of times under identical conditions. All possible outcomes of the experiment are known in advance. All possible outcomes of the experiment are known in advance. The actual outcomes in a particular experiment is not known in advance. Is called a random experiment. So for example, tossing a coin, rolling a die, drawing a specified number of cards from a well shuffled pack of 52 playing cards. Now take the example coin. See here coin diagram. So this is a 10 rupee coin, head, tail. These are the possible outcomes. When we are tossing a coin, we know that possible outcomes. One is head, one is tail. But after tossing a coin, what we are getting actual outcome, what we are getting the uppermost face after tossing a coin, or what we are getting the result, we can't expect before only. Yes or no? All possible outcomes of the experiment are known in advance. The actual outcome in a particular experiment is not known in advance. It's called a random experiment. For suppose rolling a die. On a die, how many number of points are there? You know that 1, 2, 3, 4, 5, 6. These are the possible outcomes. Already we know that. After rolling a die, what we are getting the result, we don't know. We can't expect. Okay. And cards related also. Playing cards. There are 52 cards. So without seeing the face of the card, just one pick up the card, we can't expect that what is that card, either 2 or 10 or jack or king or spade or queen, heart, diamond shape, like that. So these are the example of random experiment. Students, once again listen. A random experiment is an experiment in which the experiment can be repeated any number of times under identical conditions. All possible outcomes of the experiment are known in advance. The actual outcome in a particular experiment is not known in advance. It's called a random experiment. Students, all of you understood now? I've given 3 examples also. Next, sample space. What is sample space? The set of all possible outcomes of a random experiment is called the sample space. It is generally denoted by S. If tossing a coin, so what we are getting the possible outcomes, tell me. One is head, another one is tail. The set of possible outcomes is called a sample space. It is denoted by S. If rolling a die, what are the sample points? On die, we know that 1, 2, 3, 4, 5, 6 points are there. The set of points, we will say that sample space. Okay, what is the sample space? The set of all possible results of a random experiment is called the sample space of that experiment. It is generally denoted by S. Example, we toss a coin. There are two possible results. One is head, another one is tail. So S is equal to the set of H comma T. This is sample space when tossing a coin. If tossing two coins means we are getting two results at a time. One is head head, head tail, tail head, tail tail. Total four possible outcomes. The set of four possible outcomes, we will say that sample space. And rolling a die, S is equal to 1, 2, 3, 4, 5, 6. This is sample space. Students, all of you understood now? So what is a discrete sample space? The sample space S is a finite set. The sample space S is finite set. Finite set means it is countable. The sample space S is a finite set. The sample space S is a finite set. Then we will say that the sample space is discrete sample space. The sample space is infinite. We will say that continuous space. Continuous space. Discrete sample space means the sample space is finite. Continuous space means infinite. Infinite. These two definitions, remember it. Next. So I'm going to discuss that event. What is event means? An event is subset of the sample space. Event means an event is subset of the sample space. Yes. See one example. When a die is rolled, getting an odd number is an event. If we are rolling a die, what are the sample points? Tell me. 1, 2, 3, 4, 5, 6. This is sample space. Getting an odd number. Odd number means 1, 3, 5. This is one event. Getting off an even number. Even number means 2, 4, 6. These are the possibilities when a die is rolled. So here A is the event. Finally, what they are given, see, once again definition, an event is a subset of the sample spaces. Here, A is subset of S only now, and A is subset of S only now. So no. Now, pi is subset of S. Pi means null set. Null set is subset of the given set. In this case, we will say that pi is impossible event. Pi is impossible event. Tell me one example impossible event. When a die is rolled, getting a number 8, that is impossible event. On a die, what are the sample points? You know very well. 1 to 6. Getting a number 8 means that is impossible event. So pi subset S, then pi is called impossible event. Getting a number 10, that is also impossible event. So here in this case, pi is called an impossible event. Next, S subset S. S subset S. Then S is called sure event or certain event. Okay, students, what is the event means? An event is a subset of the sample spaces. Example, when a die is rolled, getting an odd number is an event. Getting an even number is an event. So in this case, E is subset S and A is also subset S. Null set also subset of the given set. This is already you know very well. Now pi subset sample space. Then pi is called impossible event. S is subset of S. Then S is called sure event or certain event. Okay. Now I am going to another definition. Elementary event. What is the elementary event? An event having only a single sample point is called an elementary event or simple event. Understood? What is elementary event means? An event having only a single sample point. What is sample point? In sample space, each and every point is called sample point only. If your die rolled, what is the sample space? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. These are all sample points only. An event having a single sample point is called an elementary event or simple event. For example, see that when two coins are tossed, the sample space is head head, head tail, tail head, tail tail. Then event even, only head head. Of getting both the heads is a simple event. Only one event is there. One point is there, sample point. An event having only a single sample point is called elementary event or simple event. Okay, all of you understood now? Next, mixed event, compound event, composite event. Mixed means just opposite to elementary event only. An event other than elementary or simple event is called mixed event. That means each event has at least two sample points. At least two sample points is called mixed event or compound event. Now see examples here. When tossing a coin, when two coins are tossed, the sample space is head head, head tail, tail head, tail tail. Then event E, head head, head tail, tail head. That meaning is event of getting at least one head is a mixed event. Here see that event having more than one sample point. More than one sample point. That means minimum two sample points need and more also. Okay, then we will say that the event is mixed event or compound event. Okay, if rolling a die, the sample space 1, 2, 3, 4, 5, 6, A is equal to 2, 4, 6, event of occurrence of an even number. Even number. That means 2, 4, 6. How many sample points are there here? 3 sample points are there. More than one sample point is there means that event is said to be mixed event. Students, all of you understood now? See here, equally likely events. So what is equally likely events? Two events are said to be equally likely if both of them have the same chance of happening. Two events are said to be equally likely if both of them have the same chance of happening. So the two events, we will say that equally likely. The given events are said to be equally likely if none of them is expected to occur in preference to the other. Okay. Now see one example. If tossing a coin, what are the sample space? Tell me. Sample space is head and tail. This is a sample space. What we are getting the events, that means A be the event of getting a head, A be the event of getting a head, B be the event of getting tail. These two events, observe that. These two events, observe that. Two events are said to be equally likely if both of them have same chance of happening. If tossing a coin, the outmost value, uppermost value, it is possible to get either head or tail. 50-50 chances. For suppose, if you are rolling a die, what are the sample points? 1, 2, 3, 4, 5. There are 6 sample points. Okay. After rolling a die, we are getting the results. We can expect that? No. So what we will get the result? Either 1 or 2 or 3 or 4 or 5 or 6. Any one possible. So each and every element having same chance of happening. Here small correction, 4 is missing. Here 4 is missing. Okay, students, equally likely events means two events are said to be equally likely if both of them have the same chance of happening. For suppose one student is written exam. So what we get the result? Either pass or fail. Both are having same chance of happening. 50-50 chances. Okay, right. Independent events. So what is independent events? Two events are said to be independent if the occurrence of one does not depend on the occurrence of the other. The occurrence of one does not depend on the occurrence of the other. For suppose rolling a die, what are the sample points? Already you know very well. 1, 2, 3, 4, 5, 6. E1 be the event of getting odd number. Odd numbers means 1, 3, 5. E2 be the event of getting an even number 2, 4, 6. Here observe that, clearly observe that the occurrence of odd number does not depend on the occurrence of even number. So we will say that E1 and E2 are independent events. E1 and E2 are independent events. Students, all of you understood now? Now, next definition, complementary event. Let E be an event and S be the sample space for a random experiment, then complement of E as denoted by complement of E is denoted by like this E bar R E dash R E power C. E be the event, E be the event, then E complement is denoted by like this E bar E dash E power C. Okay, now event already we know that. Then what is E complement? E complement occurs, E does not occur. E complement occur, E does not occur. Now take one example. If rolling a die, you'll get sample points 1, 2, 3, 4, 5, 6. E be the event of getting number 1, 3, 6. Then what is E complement other than E? Here in event E, we got 1, 3, 6. Then E complement means other than E. What are the numbers? 2, 4, 5. This is E complement. Or go to another example. If you are taken event E with the event of number getting a odd number, getting an odd number. E with the event of getting an odd number. Odd number means 1, 3, 5. This is E. Then what is E complement? E complement with the event of getting an even number, opposite 2, 4, 6. And by observing the Venn diagram, we will say clearly. See here, this is total sample space. Now this is the event. This is E. Then what is E complement? Outside part is the E complement. Total sample space. This is E. E complement means outside the part. This is totally E complement only. Green color part. Totally this is E complement. Are you understood, students? If an unbiased die is thrown, then sample space S is 1, 2, 3, 4, 5, 6. E be the event of getting odd number. E be the event of getting odd number. Then E complement. So E is equal to total sample space minus. So E complement is equal to total sample space minus E. This is total sample space minus E. Subtract this, these two. Subtract this. Then you will get E complement. That is 2, 4, 6. Students, are you understood? And here, one more important point. One more important point. E plus E complement, that is equal to sample space only. Here observe that E be the event of getting odd number and E complement with the event of getting even number. If both observe that, that is total sample space only. Okay, students, all of you understood now what is the difference between event and complementary event. Next, here observe that note the favorable cases to a particular event of an experiment are called success. Favorable cases means success. Remaining cases are called failure with respect to that event. The favorable cases to a particular event of an experiment are called success, and the remaining cases are called failure with respect to the event. Probability. Probability of occurrence of an event. So classical definition of probability, mathematical definition of probability, this is same. Let S be the sample space, then the probability of occurrence of an event is denoted by P of E. Then P of E is equal to N of E by N of S. What is N of E? Number of cases favorable to an event E. N of S means total number of cases. So finally, what is P of E means? Number of cases favorable to event E divided by total number of cases. Okay. Now see here, when a die is rolled, what are the sample points? 1, 2, 3, 4, 5, 6. Okay. N of S, number of sample points. How many are there? There are 6 points. Here, E be the event of getting an odd number. What is odd numbers here? 1, 3, 5. What is N of E? N of E is 3. Now we are going to find probability of getting an odd number. Odd number means event E only now. Probability of getting an odd number, that is equal to, what is the formula? N of E by N of S. That means number of favorable cases by total number of cases. Probability of getting odd number means these are favorable cases. Number of favorable cases, how many are there? 3. Total number of possible cases, totally 6. 3 by 6 means how much? 1 by 2. The probability of getting an odd number is 1 by 2. Then what is the probability of getting even number? Same, 1 by 2. Odd number, even number, both are equally likely events. So that's why we get 1 by 2 only. Finally, observe here, what is P of E? Probability definition, formula. The number of cases favorable to event E divided by total number of cases. But here important point, the probability is always lies between 0 to 1 only. Probability is lies between 0 to 1. What is the range of probability, students? Probabilities belongs to closed 0 comma 1. The probability is cannot be negative, cannot be more than 1. By observing the answer, we will say that that is correct answer or wrong answer. And here, pi is the impossible event. Then, what is probability of pi? 0. Impossible event means you know very well. What is that? If a die is rolled, number getting number 8, that is impossible event. There probability is 0. P of pi is equal to 0, where pi is impossible event. Next, second point, see that S is a sure event. Then P of S means N of S by N of S. That probability should be 1. P of E is equal to 0, then E is equal to null set. P of E is equal to 1, then E is equal to S. Finally, what is a P of pi, students? Probability of null set is 0. Probability of S, that is 1. Next, second point, most important point. If is any event, E is any event, here E is missing. E is any event and E complement with a complement of event E, then P of E plus P of E complement is equal to 1. P of E plus P of E complement, that is equal to 1 only. Probability of an event plus probability of E complement, that is equal to n. Here observe that formula. What is P of E complement, students? 1 minus P of E. 1 minus P of E. Here already explained example. Probability of getting odd number. What is probability of getting even number? This is E1, this is E2. Total probability minus probability of getting odd number, subtract 1 minus 1 by 2. You will get probability of getting even number. So this is very important formula.